Hi, welcome to Up Top Solar. My name is Gwendolee, and we will be going over how to string size a Victron solar charger. So let's get started. Also, my screen is here, so I will be bouncing between you and my screen. So today I won't be going over all the details of the string sizing tool. I have another video here that you can see that will go over that, all the different sections in more detail. All right, so in order to string size a solar charger, step one, we're going to select solar charger. Next is battery voltage. So depending on the solar charger, sometimes they will have different specs depending on the voltage that you're trying to work with. So we will select 48 volts, and then now we can see step three, which has a list of the compatible solar chargers at 48 volts. We're going to go ahead and select Victron Smart Solar MPPT 250-70. So it will upload automatically the important data for this MPPT for this smart solar charger. So when it comes to string sizing, there are many important factors, but the main two is maximum voltage and maximum current. So this one has a maximum voltage of 250 volts DC and a maximum current of 35 amps. So we need to make sure that we don't exceed either of these. The next important thing is minimum VMP. So in order to charge our 48 volt battery, we need to make sure we have a little bit more voltage than that. So we have a minimum operating voltage of 60 volts. And then for maximum PV power, this one can be a little tricky. It just depends on how the manufacturer specifies this. Sometimes they have maximum connected PV power that you can connect to your solar charger. In this case, for Victron, and actually for a lot of solar chargers, it's just the throughput. So it's the maximum output of the charger to the batteries. And this for Victron is the nominal power at 48 volts. All right, and then next is temperature. Temperature is really important when it comes to string sizing because it affects the characteristics of your module. So I'm going to leave it at -10 and 40, but you really need to know what your ambient temperatures that you're working with for your system. And if you're in Canada or the US, you can go ahead and use this database in order to find that if you don't know what that is. Next is selecting a solar module. So if you don't see the module that you're trying to size with, you can go ahead and click custom here. However, we do. So we will go ahead and find our module and select that. And also I forgot to mention, when you do put custom, you just manually enter all of this information. All right, advanced settings. So I do want to go into this because of the nature of the solar charger. So by default, this tool will do a 1.2 overloading ratio, or sometimes called an AC to DC or DC to AC ratio or DC to DC ratio, and that's by default. So I will leave this at 1.2 actually for this solar charger, and I will explain a little bit later why. But you can change this. For example, if you want to make sure that the string sizing tool only string sizes to up to a maximum of basically 1 times this 4,000 watts, then you can do that. I'm going to leave it at 1.2, which means that we will be sizing to 4,800 watts. All right, next is maximum current safety factor. So this tool is kind of catered around National Electric Code, which is based, something the U.S. uses, and this is one of the methods of calculating maximum current is this 1.25 factor. However, specifically Victron is global. It's all over the world. It might be installed in different locations with different codes or no codes. I'm not advocating to not use a safety factor or not, but I'm just saying that this is adjustable. And for the purpose of this demonstration, I will be changing this. And it just gives you a little bit of a warning saying that, hey, if you're in the US, there's a risk that you might not be following the code, which we know what we're doing. So we're going to read that, accept it, and move on. Mounting type, So this is really for commercial settings and utility scale settings or applications. That doesn't really apply here. All right, next we're going to select string size. So these are the results here. So we have a total of 5 modules in series and 3 strings. So we have our 1, 2, 3, 4, 5, and then our total of 3 strings. And we can see the results here. So this is just the default results. The string VOC is below the 250 volts maximum. The maximum current is below the 35 amps, so that's good. Going back here, we're above the 60 volts operating voltage, which is good. And because we have that 1.2 factor, our max power is going to be 4,800, and we are below that, so that's good. And for whatever reason, so this is a total of 15 modules. If let's say you only have 12 modules, you can go ahead and mess with this so that you can try to size to exactly what you're trying, like maybe your material limited or something like that. So you can go ahead and mess around with this. This warning here just gives you a little bit of a warning saying, hey, this spec here is 4,000 watts. And right now you're above that, so just making sure you know what you're doing. So it's just saying check with the manufacturer. And yeah, so one thing I did want to point out is going back to that overloading ratio. So inverters and solar chargers, they will naturally have a maximum power that you can connect to it just by using the maximum voltage limitation and the maximum current limitation. And I will demonstrate that by increasing this target overloading ratio to 3. So by increasing this to 3, theoretically this is saying that we are allowing up to 12,000 watts to be connected to the solar charger. It cleared our results, so it's going to recalculate this, but guess what? We get the same results. And that's because, again, we're limited by this maximum VOC, so we can't add another module here. And we're limited by this maximum current at 35 amps, so which means we can't add another string here. So this is the maximum array that we can have using this module with this temperature, and that will result in a 1.16. In this case, it would be an overloading ratio or a DC to DC ratio. So last part is a system summary. So we have a total of 15 modules, 3 strings, 4.7 kilowatts, and again, an overloading ratio of 1.16. And you can go ahead and click email my results, put your name, put your email address, maybe some notes that you want to put in there, and you can send the results to yourself. And what it will look like, basically it will look like this web page. It will have all the inputs, the results, all the images here in an email form. So yeah, that's how you string size a solar charger, specifically a Victron solar charger. Thanks for joining.